question often arises regarding ground fault circuit interrupter, or GFCI, protection for outlets serving microwave ovens, particularly in kitchens. Specifically, the concern is whether a dedicated outlet for a microwave oven located near a sink, in this case about 6 feet away, requires GFCI protection according to the National Electrical Code, or NEC. The answer, based on the NEC, is no. It is not generally mandatory to have GFCI protection for a dedicated microwave outlet. Let's delve deeper into the NEC requirements to understand the rationale behind this. The NEC outlines specific locations and applications where GFCI protection is required to enhance electrical safety. These requirements are primarily aimed at reducing the risk of electrical shock in areas where moisture is present or where individuals are more likely to come into contact with grounded surfaces. Article 210.8 of the NEC details the requirements for GFCI protection. This section mandates GFCI protection for receptacles installed in various locations, including bathrooms, garages, outdoors, crawl spaces, unfinished basements, kitchens, and areas near bodies of water. However, the specific wording of the code is crucial in determining whether a particular outlet requires GFCI protection. In kitchens, GFCI protection is generally required for all receptacles that serve countertop surfaces. This requirement is intended to protect individuals using countertop appliances from electrical shock hazards. Since microwave ovens are often placed on countertops, the question of GFCI protection naturally arises. However, if the microwave oven has a dedicated circuit, meaning it is the only appliance powered by that circuit, then GFCI protection is not mandated by the NEC. The reasoning behind this exception is that a dedicated circuit for a microwave oven is less likely to be used for other countertop appliances that might introduce ground fault hazards. Additionally, microwave ovens are typically designed with internal safety features to minimize the risk of electrical shock. It is important to distinguish between general countertop receptacles and dedicated appliance circuits. General countertop receptacles, which are used for a variety of portable appliances, are required to have GFCI protection to safeguard against potential ground faults. These receptacles are subject to frequent plugging and unplugging of different appliances, which can increase the risk of damage to cords and equipment, leading to ground faults. In contrast, a dedicated microwave outlet is typically used exclusively for the microwave oven and is not subject to the same level of wear and tear. Furthermore, the NEC allows for exceptions to GFCI requirements in certain cases where equipment malfunction would create a greater hazard than the absence of GFCI protection. While this exception is not directly applicable to microwave ovens, it reflects the NEC approach of balancing safety with practicality. It's also important to note that local codes and amendments may impose additional requirements beyond those specified in the NEC. Therefore, it is always advisable to consult with a qualified electrician or local building inspector to ensure compliance with all applicable regulations. In summary, while GFCI protection is generally required for countertop receptacles in kitchens, a dedicated outlet for a microwave oven is not mandated to have GFCI protection under the NEC. This exception is based on the premise that a dedicated circuit is less likely to be used for other appliances and that microwave ovens are designed with internal safety features. To provide a comprehensive understanding, let's consider some additional aspects related to GFCI protection and electrical safety in kitchens. Firstly, the purpose of a GFCI is to detect ground faults, which occur when electrical current flows through an unintended path to ground. This can happen when an appliance or electrical device has damaged insulation or a faulty component, allowing current to leak to ground. If a person comes into contact with this leakage current, they could experience an electrical shock. A GFCI works by monitoring the current flowing into and out of a circuit. If there is a difference of more than a few milliamperes, typically 5 milliamperes, the GFCI trips the circuit, cutting off the power and preventing electrical shock. Secondly, the NEC specifies different types of GFCI devices, including GFCI receptacles and GFCI circuit breakers. A GFCI receptacle is installed in place of a standard receptacle and provides GFCI protection only at that specific location. A GFCI circuit breaker, on the other hand, is installed in the electrical panel and provides GFCI protection for the entire circuit. Thirdly, while the NEC does not mandate GFCI protection for dedicated microwave outlets, there may be situations where it is still advisable to install a GFCI. For example, if the outlet is located very close to a sink or other water source, or if there is a history of electrical problems in the kitchen, adding GFCI protection can provide an extra layer of safety. Additionally, some microwave oven manufacturers may recommend GFCI protection for their products, even if it is not required by code. Fourthly, it is important to ensure that all electrical work is performed by a qualified electrician who is familiar with the NEC and local codes. Improperly installed electrical wiring or devices can create safety hazards and increase the risk of electrical shock or fire. Fifthly, regular maintenance and inspection of electrical systems are essential for ensuring ongoing safety. This includes checking receptacles and cords for damage, testing GFCI devices periodically, and addressing any electrical problems promptly. Sixthly, it's crucial to understand the difference between GFCI protection and grounding. Grounding provides a path for fault current to flow back to the electrical panel, allowing the circuit breaker to trip and energize the circuit. GFCI protection, on the other hand, detects ground faults and interrupts the circuit even if there is no grounding path. Both grounding and GFCI protection are important for electrical safety, but they serve different purposes. Seventhly, when replacing or upgrading electrical devices in a kitchen, it is always a good idea to consider incorporating additional safety features such as arc fault circuit interrupters or FSIs. FSIs detect arc faults, which are another type of electrical fault that can cause fires. FSIs are required by the NEC in certain locations, including bedrooms, and are becoming increasingly common in other areas of the home. Eighthly, it is also important to be aware of the potential hazards associated with using extension cords and power strips in kitchens. Extension cords and power strips can easily become overloaded, creating a fire hazard. It is best to avoid using extension cords whenever possible and to use power strips with built-in overload protection if necessary. Ninthly, when selecting appliances for use in the kitchen, it is important to choose models that are certified by a recognized testing laboratory such as Underwriters Laboratories or UL. UL certification indicates that the appliance has been tested and meets established safety standards. Tenthly, consider the specific requirements outlined in NEC section 210.8. This section provides detailed information on the locations where GFCI protection is required for 125 volt to 250 volt receptacles. It is a critical resource for understanding the NEC GFCI requirements. In summary, while a dedicated microwave outlet near a kitchen sink does not typically require GFCI protection under the NEC, it is essential to understand the code requirements, consult with a qualified electrician, and prioritize electrical safety in all aspects of kitchen design and maintenance. Remember that electrical codes can change, so always refer to the latest edition of the NEC and local amendments for the most up-to-date information. For instance, NEC Table 220.55 provides guidance on calculating the demand factors for household cooking appliances, which can be relevant when determining the appropriate circuit size for a microwave oven. Additionally, NEC Article 422 covers the requirements for appliance branch circuits, including those serving microwave ovens. Understanding these articles and tables can help ensure compliance with the NEC and promote electrical safety. Another important consideration is the voltage and amperage requirements of the microwave oven. Most household microwave ovens operate on a 120-volt circuit and draw between 10 and 15 amps. It is essential to ensure that the circuit is properly sized to handle the load of the microwave oven without overloading. NEC Section 210.21 specifies the allowable ampacity of branch circuits, which should be consulted when determining the appropriate wire size and overcurrent protection for the microwave oven circuit. Furthermore, the type of receptacle used for the microwave oven should be appropriate for the voltage and amperage requirements of the appliance. A standard 15 amp 125-volt receptacle is typically used for microwave ovens in residential kitchens. It is important to use a receptacle that is rated for the intended use and to avoid using adapters or extension cords that could compromise safety. Additionally, the location of the receptacle should be carefully considered to ensure that it is accessible and convenient to use, while also minimizing the risk of damage or accidental contact. The receptacle should be mounted securely and should be protected from moisture and physical damage. In addition to the NEC requirements, there may be local codes and regulations that apply to electrical installations in kitchens. It is essential to consult with the local building department or a qualified electrician to ensure compliance with all applicable codes. Local codes may have more stringent requirements than the NEC, or they may provide additional guidance on specific installation practices. Compliance with all applicable codes is essential for ensuring the safety and reliability of the electrical system. Moreover, it is important to educate homeowners about electrical safety and the proper use of electrical appliances. Homeowners should be aware of the potential hazards associated with electricity and should take precautions to prevent electrical accident. This includes avoiding contact with water while using electrical appliances, keeping electrical cords and devices away from heat sources, and testing GFCI receptacles regularly. Homeowners should also be instructed on how to recognize the signs of electrical problems such as flickering lights, sparking outlets, or tripped circuit breakers, and should be advised to contact a qualified electrician to address any electrical issues promptly. Education and awareness are key to promoting electrical safety in the home. Let's now address a common question about the differences between the 15-amp and 20-amp circuits. 15-amp circuits typically use 14 American wire gauge or AUG wire, while 20-amp circuits use 12 AWG wire. This difference is important to note as it affects the current carrying capacity of the circuit and the type of receptacle that can be used. It's generally accepted that 20-amp circuits have a higher capacity for handling power-hungry appliances. Moving on, it's a good practice to understand the concept of electrical load calculations in accordance with NEC Article 220. This helps in determining the total electrical load of a kitchen, including lighting, receptacles, and appliances. The load calculation is essential for selecting the appropriate size of the service panel, feeders, and branch circuits to ensure the electrical system can safely handle the anticipated load. Load calculations also consider demand factors, which are reductions in a calculated load based on the likelihood that all appliances and devices will not be used simultaneously. It is imperative to always ensure that all electrical work adheres to local codes and regulations. These codes might have stricter requirements compared to the NEC. A local building department or a licensed electrician can provide assistance to ensure adherence to these codes. In summary, when addressing the question of GFCI protection for a dedicated microwave outlet near a kitchen sink, it's critical to look at the NEC requirements, the specific application, and the potential hazard. A thorough comprehension of the codes, safety measures, and best practices will ensure secure electrical installation. Remember, it's always wise to seek guidance from qualified professionals when working with electricity to ensure safety and code compliance.